Good morning, all of you. I hope all of you are studying the lessons. Please keep reading the textbooks. We are almost at the verge of finishing the lesson Atomic Structure, children. Hope you have done all the homeworks, the definitions which I gave. Whichever tables had to be made on the blank pages should have been done. Now, last class we discussed these diagrams, remember? And you should have learnt atomic numbers 1 to 20, children. Every class I am repeating this. Atomic number 1 hydrogen, 2 helium, 3 lithium, 4 beryllium. Come on, speak up with me. 5 boron, 6 carbon, 7 nitrogen, 8 oxygen, 9 fluorine, 10 neon, 11 sodium, 12 magnesium, 13 aluminium, 14 silicon, 15 phosphorus, 16 sulfur, 17 chlorine, 18 argon, 19 potassium and 20 calcium. In the same order you have to learn and remember all of these. Very, very important to do this. Now, in the nucleus are located our protons and neutrons. Outside are our electrons. How electrons, the total number of electrons, which is also equal to the total number of protons. How they are filled? The way they are filled is known as the electronic configuration. And the first shell can hold maximum 2 electrons and rest all shells can hold 8 electrons. We discussed about the noble gases also last time. Remember? Now why do we call them noble gases or inert gases, children? Helium, neon, argon. They are called noble gases. They have no effect of any element which is coming nearby. They are inert. We will remain the same. Let any element come and go near us. Okay, so they are inert, they are satisfied, they are noble. No reaction to anything. Okay, why is it so? All of these have one thing in common. Their shell, outermost shell is complete. Complete means if it is helium, K shell should have 2 electrons and it has 2 electrons. So this is complete shell. L shell should have 8 electrons and it has 8. Similarly, M shell should have 8 electrons. Remember the octet rule, the outermost shell can have maximum of 8 electrons. So because of this, it has 8 electrons and it is also considered as complete. Okay, so this is what the octet rule says. One thing common which is there in all noble gases, because of which they do not show any kind of reaction, is that their outermost shell is complete. Right? Now why am I talking about all this? All other elements, their outermost shell is not complete. So all elements want to behave like noble gases. They want to be stable and inert. They want to be like noble gases. Okay, so all of them would want that their outermost shell should be complete. In order to satisfy this, they try to complete their outermost shell by either giving electrons or taking electrons. Okay, so we can say that why do atoms combine? They combine to attain stability. Okay, just they want to be stable as noble gases, as they have incomplete valence shell. Valence shell is the outermost shell. Okay, so they want to have chemical stability, want to attain chemical stability, and they want to complete their incomplete outermost shell. Okay, now if I talk about any of these atoms, suppose I talk about here lithium. Lithium has 2 electrons in the first shell, 1 electron in the second shell. Lithium, since it is near to helium, it will want that it should have 2 electrons in the K shell. How will it attain stability? By becoming like this. Now whenever atoms combine, definitely the nucleus can never be touched. The nucleus will definitely remain the same. It has 3 protons, 4 neutrons. It will be 3 protons, 4 neutrons only. What can only change and attaining stability can only be done with the help of electrons. And elements always combine by the combination of electrons. Protons, neutrons are never touched. Please remember this. What we can change is only the number of electrons. How can we change? We were talking about lithium, outermost shell, 1 electron. Suppose this 1 electron is taken off. It is given. Don't you think this shell, which is an imaginary path, will no more be there? And this will become the outermost shell, K shell, which will have 2 electrons just like helium. And then it will be a stable substance, because the outermost shell is the K shell, which has 2 electrons just like helium. Now, in the process of losing 1 electron from here, it will have 3 protons but only 2 electrons. That means it has 1 extra of positive charge. This positive charge makes lithium Li+, which is lithium ion. Okay, and such an ion which has a positive charge is known as cation. So lithium, when it becomes Li+, is a stable ion, right? Beryllium, these 2 electrons it can lose and become stable. So what will it become? It will become Be+2. Okay, beryllium cation. Talk about boron. Boron, 3 electrons it will lose and it will become B+3. Right? Now, after boron comes our carbon. Now, carbon is an element which shares electron. It has 4 electrons. Now, this sharing of electrons you will study in higher classes, children. So, for now you can just remember carbon and all the elements which have 4 in their outermost shell, they will share electrons, neither giving nor taking. Okay. We move on to nitrogen. Now, this nitrogen has 1, 2, 3, 4, 5. It can give away 5, but another method is it can take 3 electrons. If it takes 3 electrons from some other element, of course, it will have 1, 2, 3, 4, 5, 6, 7, 8. Now, 8 electrons in L shell. Don't you think it is complete? Just like the configuration of the next noble gas, neon. Okay, 8 electrons in the outermost shell. So, giving 5 is easier or taking 3 is easier? For nitrogen, taking 3 electrons is easier. When it takes 3 electrons, it has a total of 10 electrons. Total. 8 in the outermost shell and 2 inner shell. Total of 10 electrons, but it has only 7 protons. So, how many extra negative charges it has? 3 negative charges extra. So, nitrogen, this is the symbol of nitrogen, it becomes N-3 by taking 3 electrons. And when an element takes up electrons and becomes negatively charged ion, such an ion is known as anion. What were these positive ones? Cations. Okay. So, this was about nitrogen. Similarly, oxygen will take 2 electrons. 6 are already there. It will take 2 and become O-2. Fluorine will take 1. F- it will become. This is noble gas. Then this again, sodium. It has only 1. So, children, 1 electron is easier to lose rather than taking 7. Okay. So giving of 1 electrons makes sodium Na plus cation. Here Mg plus 2, aluminium plus 3, silicon, leave it, phosphorus, see 1, 2, 3, 4, 5. So again phosphorus, for phosphorus taking up 3 electrons is easier and it will become P minus 3. Okay, to have an octet configuration. Sulfur will take up 2s minus 2, chlorine minus 1, noble gas. Potassium, 1 electron in its outermost shell, it can lose this, so K becomes K plus. By losing electron, calcium becomes, because it has 2 electrons in its outermost shell, it becomes Ca plus 2, a cation. So how many ever electrons an atom takes up or loses, that is actually the valency of that atom. Okay, whichever, suppose we are talking about this, beryllium lost 2, so valency is plus 2. Nitrogen took or accepted 3 electrons, so valency is minus 3. Sodium valency is plus 1. We can write plus or plus 1, it is the same thing. So instead of writing plus 1, we can simply leave it Na plus, K plus, plus 1 or K plus, same thing. Phosphorus valency is minus 3. So the number of electrons lost or gained actually is the valency. And how are they combining? Sodium, the example which is given here, see sodium loses 1 electron, right? And chlorine gains 1 electron. So sodium loses 1, and that electron which is lost by sodium is taken up by chlorine. That is why one element gives, the other is ready to take, such so that a compound is found between these two, sodium and chlorine. What is the compound? The common salt which we eat, right? So this is how both of them have combined. So basically this is why we say valency is the combining capacity of an atom. Okay, this is how with the help of valence electrons they combine, right? So valency is the combining capacity of an atom or of an element. Valency, earlier times children, valency they used to consider with the number of hydrogen atoms. Like for example HCl, what is the valency of Cl here? It is the number of hydrogen atoms which are combined with Cl. So the valency of Cl here is 1 because 1 hydrogen atom has combined. Valency of sulfur here 2 because 2 hydrogen atoms have combined. Now sulfate is one group which I will teach you in the next class, sulfate radical. The valency of sulfate here, this whole group valency is 2 because 2 hydrogen atoms are combining here. Okay, now I hope you have understood all these, and now we will discuss the back exercises. Dalton said that atoms could not be divided. Okay, an ion with a positive charge, cation. The outermost shell of an atom is known as valence shell. Nucleus of an atom is very hard and dense. The neutrons are neutral particles having mass equal to that of protons. Isotopes are the atoms of same element having same atomic number, different mass number. True and false. An atom on a whole is neutral. So this is false. Maximum number of electrons is 2. So this is false. Central part of an atom is the nucleus. This is true. Give one word. Subatomic particles with negative charge, electrons. Protons and neutrons present in the nucleus, nucleons. The electrons present in the outermost shell are the valence electrons. Arrangement of electrons in the shells, that is electronic configuration. Number of protons present in the nucleus, atomic number. The sum of number of protons and neutrons, mass number. Atoms of same element with same atomic number, different mass number, isotopes. The smallest unit of an atom which takes part in a chemical reaction is an atom. Now what you are supposed to do, children, today in the assignment, you will write all these. On the rule sheet you will write main features of Dalton's atomic theory. Okay, and you will make the diagram of Rutherford's experiment. How you will write? Rutherford alpha particle scattering experiment. You will make this diagram and then you are going to write observations and conclusions. This part from here till here, clearly giving the headings, observations and conclusions. Right? You have to make the diagram on the blank page and observations, conclusions to be written on the rule sheet. Okay children, please keep completing your work. Have a good day.